Now, we think of this composition as an operation on functions in the same way that addition and multiplication are operations on numbers. And so we can ask the question, what are the properties of this composition of functions? And the first one that we find is that the composition does have the associative property. So if I want to compose three functions, I can compose the second two and then compose with the first one. Or I can compose the first two and then compose with the last one, keeping in mind that order still matters. So let's see an example that demonstrates associativity. This doesn't prove that the composition is associative, but at least it demonstrates that associativity works in one example. So here I have three functions, f, g, and h. And I want to compose all three of them together, doing h, and then g, and then f. So in both cases, I've written f first, then g, then h. And what I want to show is that it doesn't matter whether I take g composed with h first or take f composed with g first. When I put all three of them together and simplify, I end up with the same function. And I've chosen three linear functions here so that anything that we get anywhere along the way, we're going to know how to simplify. So on the left, I'm going to start by taking g composed with h. So g composed with h of x, that means I'm going to take g and I'm going to apply it to h of x. In other words, I'm going to take g and apply it to 1/5 x plus 3. Now g is the function where I take 3 times the input plus 1. And in this case, the input is 1/5 x plus 3. And now I'm simplifying this and I'm thinking of the composed function g composed with h. So I'll distribute. 3 times 1/5 is 3/5. I'll have 3/5 x plus 9 plus 1. My composed function g composed with h of x is 3/5 x plus 10. Now I want to take that and compose it with f. So I'll take f composed with g composed with h of x. So that's going to be f of g composed with h of x. So I'm going to take my function f and apply it to 3/5 x plus 10. Now f is the function that takes 5 times its input and subtracts 2. Here the input is 3/5 x plus 10. So we'll simplify. Distributing the 5 times 3/5 is just 3. 5 times 10 is 50. And then we've got minus 2. Composing all three, we get the function 3x plus 50 minus 2 is 48. Okay, what if we did f composed with g first? So we're going to say f composed with g of x. That'll be f applied to g of x, which is f applied to g of x is the function that takes 3x plus 1. And so f is the function that takes 5 times its input and subtracts 2. Now its input is 3x plus 1. Next we simplify, distribute the 5. So we'll have 15x plus 5 minus 2. And so f composed with g of x is 15x plus 3. Okay, now we want to compose that with h. So we're going to say f composed with g composed with h of x. That means we want to take f composed with g and we want to apply that to h of x. So we want to take the function f composed with g and apply that to a fifth x plus 3. Now f composed with g, that's the function that says take 15 times my input plus 3. And now the input is a fifth x plus 3. Simplifying, we'll distribute the 15. 15 times a fifth, we have 3x plus 15 times 3 is 45. And then we've got plus 3. And so f composed with g, then composed with h, is 3x plus 48, which is the same function that we got in the other direction. Now, this is a little bit tricky because while this operation is associative, we have to still be careful of the order in which the functions appear.